Well, hello there. Welcome back to my channel. And in this video, we are going to cover the implementation of a MQTT client using Python. We are going to write two pieces of code. One will be responsible for publishing messages to a particular topic in MQTT broker, and the second one will be responsible for subscribing to a particular topic and receiving those messages from the same MQTT broker. So let's begin with the Python coding. Well, before we move forward with the Python code, we need to install a library that will make our lives easier to communicate or to create an MQTT client. So in this case, we are using something known as paho MQTT. You can simply use the pip package manager or pip package manager to install paho MQTT. In that case, you just need to search for the exact name, which is paho-mqtt. So simply type pip install paho-mqtt in your terminal, and then the library should be installed. And now let's have a look at the code. So what I've done is that I have created a folder, and in that folder I've kept two files. One is pub.py, one is sub.py. So pub.py is basically responsible for publishing this particular data information or data packet to a particular topic, and sub.py is responsible for subscribing to this topic, and whatever information is being published to this particular topic, it will receive it. There are multiple methods that I have used to make the code look a bit simple. We'll go through each and every one, and then by the end of this video it will be more clear. Well, to begin with, let's go to our function named handler. So here what I've done is simply I have defined the parameters that are required, which is MQTT host, the port number, the username, password. So since we are using an openly available or publicly available MQTT broker, which is mqtt.eclipse.org, which is hosted over port 183, and since this is open, we are not going to use any username and password. However, I have kept this two fields there in the code, such that if you're using any broker which has additional security, then you simply populate your username and password and you should be good to go. After that, we have called a method init underscore MQTT, and we are passing all the values. So client is basically the object that we create at the very beginning, basically the object for this MQTT class. So client is equal to mqtt.client. We have created this object client for the MQTT class, and we are passing the client object, the MQTT host, the MQTT port, the user ID, and the password. Let's have a look at the init MQTT method. Well, in the init underscore MQTT method, what we have done initially, we have declared a connected flag, which simply determines whether our the Python script is connected to the MQTT broker or not. In line number 37, we have commented out a specific line which is required if your broker requires an username or password. In that case, you simply need to uncomment this particular line, as well as send the user ID and password in the previous function, that is handler. Moving on, in line number 38, we have client.on_connect is equals to on_connect. So here what we are doing is essentially setting all the callbacks. So whenever we try to connect with the MQTT broker, on_connect will be triggered. When we are trying to disconnect, on_disconnect. When you're trying to publish, so this all will be triggered based on whatever events. For connect we have, for disconnect we have, for publish also we have, as well as we have for subscribe, which we are going to discuss it when you are seeing the subscribe code. Then in line number 41, we are simply calling the connect function, where we are passing MQTT host and the MQTT port as the parameter. So once this is called, this connect method, this callback gets triggered. after a connection has been, either if it's been established or if it is not established as well, this on underscore connect will be triggered. So here we have mentioned the flag as connected underscore flag as true and disconnect flag as false. We are printing connected along with the RC value. So based on this RC value we can determine, so based on this RC value we can determine whether we had a successful connection or whether that connection was unsuccessful. I have not yet handled that part well out here, but it can be handled using the RC value. For example, RC0 means everything was success, while RC4 stands for there was an authentication error. The documentation is available in the paho MQTT PIP package manager page. So once this connect is called, we are simply passing all this, and this gets triggered and the connection is established. Next, what we have done is that we have used client.loop underscore start. Now what it does is that it creates a new thread and calls client.loop method. So client.loop method means it handles the connections, or rather the connection state for your Python script to the MQTT broker. And this loop underscore start handles the connection related events as well as the disconnection related events. If the connection is not established, it will try to reconnect itself. All these are handled internally by loop underscore start. Since it creates a new thread, so all these are handled internally. Well, if you're using loop, which I recommend not to use, then you need to manually handle all these things. In line number 44, we have used a while loop such that if it's not yet connected to our MQTT broker, it will keep on continuing until and unless we have a connection. We are simply printing in wait loop, that's it, and we are having a delay of 1 second. This usually happens when it's a slow server or you have a slow internet connection to connect to MQTT broker. So that's all for the init underscore MQTT method, where we are simply declaring the callbacks, we are connecting to the MQTT broker, and finally we have used a while loop to make sure whether everything is on track or not. Coming back to the handler method, in line number 56 we have another while loop, where again as a in this while loop we are using, it's kind of an infinite loop as long as our broker is connected. Why? Because connected underscore flag under client object is true whenever there is a successful connection. Now if I replace this with while true, that's an infinite loop. So what this will do is simply it will publish, using the publish method, a value to a particular topic on an infinite loop after a delay of 1 second. So each message will be published 1 second. So in the published method, we again have two parameters. The first one is the MQTT underscore pub topic, which is a topic, and the second is the message that you want to send. Both are accepted as string. So for avoiding confusion, I have simply typecasted it to data type string. I'm simply printing whatever information I'm sending and a simple delay of 1 second. Now there are a couple of more callbacks. One is for on underscore publish, which gets triggered whenever you're publishing any data. The second is for on underscore disconnect, which gets triggered when we are actually disconnecting our MQTT client, which I'm not doing here. And under on underscore disconnect, you will see that I have obviously set these flags to false and true, the connected as false while the disconnected as true, as well as the I have called loop underscore stop, which will stop your thread that was created in loop underscore start. In this way you can handle disconnection properly. And if by chance you are subscribed to any topic, then you can simply unsubscribe it here. And finally, under we have if underscore name equals to main, we are simply calling the handler method. Now let's execute this code. You won't see the results since I'm not running the subscriber code. What you will see is whatever information we're publishing. So initially, see, we have used, it's in wait loop simply because we have this thing configured, so it will just wait until unless this thing is connected. And we are publishing this particular JSON, which is nothing but this dictionary that we defined earlier under config_data. So that's it about the publishing to your MQTT broker. It's plain and simple, no complication, nothing is there. Now let's have a look at our sub.py Python code, where we are actually going to intercept this data. So in sub.py, what we are doing is simply whatever we are publishing in pub.py, we are simply intercepting that particular value and simply printing it in the console. Again, if the structure is more or less mostly same except some differences. So if you go to handler, you will see like similar way we have done it earlier. We have passed it to init MQTT, and under init MQTT we have declared all the callbacks, and we have simply initiated a connection and nothing else. Now coming back to our handler method, you can see that we have used client.loop_forever. So it again creates a thread and it's a blocking statement. So whatever you are writing after this loop_forever, it won't work since it's a blocking statement. So let's say if your code is only responsible for subscribing to a topic and getting those values or data, then it's recommended to use loop_forever. Else you have to stick back to loop_start and loop_stop combination. So here there is an important thing to notice is that in the onConnect under this onConnect callback, we have subscribed to a particular topic, which is MQTT/avru171, and here we didn't do that because we are not we are not subscribing to any topic under pub.py. So here under pub.py's onConnect, we have not done anything as such. We are simply publishing to this topic, and we have subscribed to this particular topic in sub.py, which is MQTT_sub_topic. We have used client.subscribe method, and the parameter we are sending is the topic that we want to subscribe to. Similarly, we do have a callback for subscription. So on_subscribe we have already defined in init_MQTT method, that is client.on_subscribe is equals to on_subscribe. So it basically what it does is like it sets the callback for subscription. So what it will do is simply like print this message after it has successfully subscribed to the topic. Now under on_message, which is again important as another callback which is required in this section, in line number 31 we have defined that. So what happens here is that whenever we have an incoming message to a particular topic after my code has subscribed to, so whenever the message is incoming, this on_message callback gets triggered. So here what we have done is that we have used a message object to print the payload which contains the actual message, and also print the topic, that is from which topic it is coming. So as of now we have simply subscribed directly to MQTT/avru171. Now if we have used a wildcard which is hash, then we could have be specific, or it could have been better to know like from which topic the message is coming from. In this case, this particular line doesn't make any sense since we are subscribed to only MQTT/avru171. However, just you can it's good to know that the message object contains payload and topic, which is useful to probably drive some business logic. So that's about the on_message callback, which gets triggered whenever a message is incoming. So other than that, most of the stuffs are pretty much same and straightforward. I have not discussed about the QoS level or quality of service level. So client or subscribe does contains a parameter for QoS as well, but we have not used that one as of now. Now let's run our code and see whether we are getting the message this as well as a topic. So as you can see, we are this message received. We are receiving this message as well as from what topic it is coming from. Since we are publishing the MQTT /w171, so simply we are getting that message. Very straightforward. Now let's do one quick thing. What I'm gonna do is that I'm gonna replace this with a wildcard. And now what happens is basically what is happening when I'm declaring as hash. So whatever messages are being published to the topic MQTT and all of its subtopics. So MQTT /subtopic. So whatever messages are being printed to any one of the subtopic for MQTT, those all messages will be received by me. So again, I'm going to execute my code. As you can see, I'm still receiving those messages, and now this topic part is useful. Now let's go back to pub.py and let's send to a different topic. Let's say it's w171. Let's just send it to, let's say, what do you use? Let's say GDG Siliguri. So I'm gonna start the publishing code again, and as soon as publish it, I am receiving all those messages here as well. Since I have used MQTT /hash, so whatever subtopics I do here, whatever subtopics I publish to under a topic MQTT, I will be receiving it here. And from which topic we are getting it, we can simply use message.topic to segregate from whatever topic it is coming from. So yeah, that's it. It's pretty much simple, straightforward. All of this code will be available in GitHub as mentioned in the description below. Well, hello there. I hope you like this video about implementing MQTT client in Python, and even if you did not like it, please share your feedback, what was wrong, such that I can rectify in the future. Please hit the like, share and subscribe button as usual if you wanna be updated or posted for new videos which I'm trying to release every weekend. So up till then, stay safe, stay in your home, and meet you soon.